Communication is central to what a PLC does. Therefore, understanding communication concepts is critical to understanding PLCs. PLCs communicate with many other devices and systems in various ways. In some situations, a PLC connects directly to another device. Often, however, various components of an automation system, including PLCs, are interconnected using network technologies. Serial communication is the most basic form of data communication used by PLCs because it involves transmitting data one bit at a time on a signal line and receiving data in the same fashion on another signal line, or in some cases the same line. A PLC uses serial communication with a variety of devices such as personal computers, printers, RFID readers, and barcode scanners. Serial communication uses interface standards such as RS-232, RS-422, and RS-485 that identify the signal lines available for communication. All three types of interfaces can be used for point-to-point communication. RS-422 and RS-485 also can be used for a multi-drop configuration with multiple devices connected on the same set of signal lines. Connecting a PLC to another device via an RS-232, RS-422, or RS-485 interface often requires a communication module. For example, the accompanying graphic shows S7-1200 communication modules used for serial communication. In most factories, the need for rapid information flow is critical. This often requires intelligent devices such as PLCs, drives, computers, HMIs, and some actuators and sensors to be interconnected by one or more local area networks, LANs. A LAN is a communication system designed for private use in a limited area. LANs are used in office areas as well as in manufacturing environments. However, LANs used in industrial applications must be able to operate reliably in conditions that are unsuitable for office equipment. Issues such as data rate, the number of devices to be connected, the reliability and noise immunity required, compatibility with other networks, and cost are examples of important industrial network considerations. Another important characteristic that defines networks is the network topology. The topology of a network is the pattern formed by network devices. Examples of network topologies include star, tree, linear, ring, and combined topologies. Some networks allow all of these topologies, and other networks are more limited in the types of topologies available. No single topology is best for all applications, so careful consideration should be given when choosing the specific topology for a network or portion of a network. A variety of cable types are used for industrial network communication. Two types of cables used for industrial Ethernet, including profinet, are shielded twisted pair cable and fiber optic cable. Shielded twisted pair cable consists of twisted pairs of copper wires with a layer of braided wire between the outer plastic jacket and the interconducting wires to provide protection from external sources of electrical noise. Fiber optic cable is recommended for use in applications with high levels of electrical noise, where grounding problems exist, or where electrical isolation is needed. These cables are also used in open-air systems or where no electromagnetic radiation is permitted. Profibus networks also use various types of shielded twisted pair cables. AS interface networks, however, use a two-wire cable that carries both data and power. Wireless network devices send and receive signals through the air. Wireless networks are used where devices must be mobile or where it is too expensive or difficult to run cables. For example, the accompanying graphic shows a mobile panel that allows an operator or maintenance person to monitor a system without being tied to a control room. Wireless networks are also used where the controlled equipment must be mobile, such as with automated guided vehicle systems, overhead monorails, and cranes. One of the most popular types of factory wireless networks is IWLAN, which stands for Industrial Wireless Local Area Network. IWLAN uses devices with antennas to transmit and receive radio wave signals. There are a variety of antenna types used with IWLAN. This includes Coax radiating cables, one of which is shown in the foreground in the accompanying graphic. Coax cables are used as antennas from IWLAN access points. Openings in the outer conductor of the Coax cable provide a defined signal strength along the entire length of the cable, enabling reliable radio links in areas where conventional antenna technology is impractical. For example, this unique antenna design allows Coax cable to be laid in the rails of an overhead monorail track where standard antenna technology is very costly to install and maintain. A field bus is an industrial network used for distributed control, and the most popular field bus is profibus. The two most common forms of profibus are profibus DP for factory automation and profibus PA for process automation. Both types of profibus are open standards of Profibus and Profinet International. Some Siemens PLC CPU models have one or more built-in profibus DP ports. Siemens PLCs also allow a communication module to be added for profibus DP communication. Profibus is a master-slave system. A slave device communicates only when requested to do so by its master device. A profibus master can control up to 125 slaves connected to the master in a linear topology. Profibus uses copper or fiber optic cables, but infrared communication is also supported. Profibus has a maximum data rate of 12 megabits per second. Profibus has two classes of master devices. Most communication is handled by a Class 1 master, which is often a PLC. A Class 1 master controls all communication with its slaves. Most of this communication is handled through a cyclic polling process. A Class 2 master is used for configuration, maintenance, and diagnostics and can communicate with Class 1 masters and their slaves. AS Interface ASI is an open, low-cost network endorsed by the AS International Association that simplifies the interconnection of actuators and sensors with controllers. ASI replaces the complex wiring and proprietary interfaces often used with this interconnection with only two wires which transfer both data and power. ASI is most often used where actuators and sensors are distributed throughout a machine or facility. In an ASI network, a master communicates with up to 62 slaves through a cyclic polling process. The master is often a PLC with a communication module. The master, slaves, and 30 volts DC power supply are interconnected by the two-wire ASI cable. IO-Link is another actuator sensor communication system. IO-Link is an open communication standard developed by the IO-Link research group of Profibus and Profinet International in response to the need for a simple, low-cost way to allow actuator and sensor communication in a concentrated area, such as for a control panel or individual machine. I/O link is a point-to-point system, not a field bus. It uses a 3-wire cable, 24-volt DC power supply, and an I/O link master. Depending upon the master, up to 16 devices per master are allowed. The accompanying graphic shows 2 examples of I/O link masters and some of the many I/O link slave devices that can be used with Siemens PLCs. Ethernet was developed in the 1970s to network office computers. As the use of computers increased in both the office and the factory, the need for common communication approaches led to the development of industrial Ethernet, which uses industrial switches to provide the performance and reliability needed for high-speed factory networks. An industrial Ethernet switch is an active network component that allows multiple devices to communicate simultaneously at high speeds. Industrial Ethernet allows communication speeds of up to 100 megabits per second with full duplex operation, which means that devices can simultaneously send and receive data. The Siemens SematicNet product family includes Scalance industrial Ethernet switches designed to fit varied requirements from localized to plant-wide networks. Siemens also offers an extensive array of devices for interconnecting network components via twisted pair cable, optical fiber, or wireless signals. For example, Siemens Fast Connect system includes cables and connectors designed for demanding factory applications and assembly tools designed to speed installation. Profinet is the open industrial Ethernet standard of Profibus and Profinet International and the leading industrial Ethernet standard. Profinet I/O, the most widely used form of Profinet, extends the benefits of standard Ethernet communication to distributed field devices by simultaneously handling 3 communication performance levels. Non-time critical communication uses standard information technology protocols. Real-time RT communication works well for most control tasks. Isochronous real-time IRT communication handles the most time-sensitive tasks such as motion control applications. Because Profinet is an open standard, it allows field devices from many suppliers to be easily connected to the network. Profinet also protects investments in existing networks by simplifying their integration into a factory-wide network. The accompanying graphic shows an example of a few of the system types that can be easily integrated into the network. In a Profinet system, the number of devices is not restricted. Profinet uses copper or fiber optic cables, but also supports industrial wireless local area network (IWLAN) communications. Devices on a Profinet network are connected through a switch. Siemens offers a variety of standalone network switches, and as shown in the accompanying graphic, many Siemens control devices have a built-in switch with 1 or more Profinet ports. Devices with 2 ports simplify use of a linear topology or a combined topology that includes devices connected in a linear manner. The following Profinet device types are shown in the accompanying figure: I/O controller, I/O device, I/O supervisor, and proxy. A Profinet system includes at least one I/O controller with I/O devices assigned to it. The I/O controller is typically a PLC or other control system which configures the I/O devices and exchanges data with them but does not control their communication. An I/O device in this context is not a PLC input-output device, but a profinet-compatible electronic device that often allows actuators and sensors to be connected. An I/O supervisor, which is often a programming device, human-machine interface, or personal computer, is used for commissioning, monitoring, and diagnostics. A proxy is a device that connects a profinet network to a field bus such as profibus. Because the proxy maps the subnetwork to profinet, all the devices of the subnetwork are available for profinet. These profinet device types have been part of the standard since its inception. Later innovations to profinet I/O include the following device types: shared device and iDevice. The shared device capability allows two I/O controllers to use the same I/O device. This is accomplished easily by copying the configuration from one I/O controller to another. The benefits are reduced costs for equipment, engineering, installation, and maintenance. iDevice is short for Intelligent Device. An iDevice is a local I/O controller that is also an I/O device for a central I/O controller. The central I/O controller has direct access to the input-output image in the local I/O controller, so communication is simple and fast, and no complex programming or additional communication hardware are required. Profibus and Profinet International (PI) has working groups with representatives from many companies, including Siemens. These working groups specify configurations of Profibus and Profinet devices that meet special requirements. The specifications are published by PI as profiles. Profiles are open and vendor neutral, allowing users to incorporate products from multiple suppliers into their systems without concern for interoperability. In addition to the Profinet I/O profile, which provides for the integration of distributed field devices via industrial Ethernet, examples of PI profiles are ProfiDrive, ProfiSafe, and ProfiEnergy. ProfiDrive and ProfiSafe were initially developed as Profibus profiles and later extended to include Profinet. ProfiEnergy is a Profinet profile. The ProfiDrive profile allows users and OEMs to design machines and processes with drives from multiple suppliers communicating via Profibus or Profinet. ProfiSafe is an integrated safety technology applicable for both discrete manufacturing and process automation, which permits the transmission of standard and safety-related data on a single bus cable. The ProfiEnergy profile enables the design of systems with controllers such as PLCs that can signal equipment, referred to as energy-consuming units, ECUs, to begin a sleep mode at the start of a planned pause or unplanned work stoppage. Software in each ECU determines how the sleep mode is implemented. When the sleep mode is over, the controllers signal the ECUs to resume operation. The use of ProfiEnergy configurations enables substantial energy savings without a reduction in productivity. Profibus and Profinet International PLCs. This chapter has provided you with information on somatic modular PLCs, PLC inputs and outputs, and PLC communication. The concepts and terminology discussed in this chapter will be useful to you in furthering your knowledge of Siemens PLCs.